Alright, hello, welcome to a new video in this problem called Reverse Linked List 206 on LeetCode. I've done it before, but I kind of forgot. Things have been like a couple months. So we'll see if I can solve it right now. So I'm not on my setup right now. So it looks different. In LA. Woohoo! Alright, so let's solve this with my problem solving process. Yeah, let's get into it. So given the head of a singly linked list, reverse the list and return the reverse list. Pretty simple prompt. So for input, we're given head of linked list, and for output, you want the same linked list but reversed. And then I guess to note, I guess I don't think there's anything to note because that's pretty much it. I guess some questions, I guess. So some questions are, can the linked list size be 0? Let's see. Let's scroll down. It says, yeah, that it can be 0, so yes. Okay. And then, yeah, I don't think the maximum size matters. I think only the minimum size matters here. So now that we've gone through some questions, that's all the questions I have. I guess we can go over some examples. They're pretty simple. I mean, so let's say our input's like 1, 2, 3. Of course, the output's going to be 3, 2, 1 because it's reversed, right? But I think these examples would help us out when we're actually trying to code it up. So let's do that. Let's do that, and then let's say we have inputs 1 and 2. Our output should be 1. Um, yeah, that's pretty much it. So I do understand it, but the hard part is just coding it. So let's go into the matching phase where we can figure out what tools we can use to solve this problem. From previous problems, we use pointers to kind of do some repointing of pointers. Repointing of nodes is next. So I guess we can use pointers. I'm not sure how many pointers, but maybe three or two. One to, I think we can need a previous, and then one for current, and then next. We'll see. And then we can obviously use a while loop. So a while loop, we can use to iterate through linked lists, and then maybe an if statement. If statement, just in case like the list is like 0 or size is 0. I don't know. So yeah. Now that we know the input and output, we asked some questions, we went through some examples, and we know what tools we can use to solve this problem. Let's go ahead and solve it by making a plan. Before I make my plan, I'd like to make my driver code first. Then I'm going to name this function to solve the problem called get reversed linked list. So take in the head. And then I'm going to make a class of list node. So class list node. Self and value is equal to 0 and next is equal to none by default. And I'm going to say that self.val equal to the val we're given, and self.next is equal to the next we're given. All right, so that's our class list node. All of our stuffs basically. Yeah, so let's go ahead and solve it. Or I mean, not solve it, but make a plan. First off, we want to kind of iterate through the list. And then what we want to do is we want to reverse the list. But how do we do that? How do we do that? Can you go over it with the Jamboard? Our examples that we did. So 1, 2, and 3, and 1, 2. So 1, 2, 3, 2. Right, that's good enough. Make it bigger. All right. And so when we go through the list, I mean, when we iterate through the list looks like this, like 1 points to the 2 to 2 points to the 3. But we kind of want to reverse that in such that it looks like this, right? Like this is the head. No, this is like the big, yeah, I don't know. But yeah, so you know what I mean. So, what do I want to do? Hmm, what do I want to do? So what I want to do is let's see. So how am I gonna do this? I'm gonna just do like name them like pointer one, and pointer two, and pointer three, because I don't really know how to solve this. But I definitely know that we need pointers to solve this. Let's start off with 2 pointers. Like maybe we can add the third pointer if we need to. Right. So let's say we start at pointer one and pointer two. Right. They start at this one. Um, what we really want to do is we want one of these pointers to point at two, right? And then we're like, okay, so two, we're going to point to this one, right? But how do we actually do that, right? Because we need to do some operations first. And we can't just say that pointer two points to pointer one because we'll lose this three. So what do we do? All right, what do we do? Um, because it would make sense if we had a third pointer that kind of points to pointer two's next in a way, I guess. Where it's like, okay, so pointer two, pointer two points at pointer one, right? Pointer two points at pointer one, and we lose this, right? That's fine because we have this pointer three here. So we can lose this three. So, and then this one point still points to two, still points to two, which is kind of weird because we don't want that to happen. We want to actually like reverse it. So what can we do here? Um, to initialize it first, we can say that pointer two starts at here. It goes at nothing, right? Pointer two starts here at nothing. Then pointer one points to pointer two, right? And so I guess what we can say is that we can say pointer one points to pointer two at nothing, right? Um, but before that, because we don't want to lose pointer one pointing to two, like we don't want to lose two in this case. So what we do is we say before we do that operation, pointer three is going to point to pointer one's next. Let's write this down. So we can do that by saying p1. Um, yeah, I guess we can just say so initialize 3 pointers. Pointer one points at head, and then pointer two, none, and then pointer three points at dot next, I guess. So yeah, that makes sense. Um, yeah, so what we can do, we can say points at head initially, but points to next, I guess. So I guess we can say that pointer three is next. Pointer three is next, and pointer two is previous. Pointer one is current. So yeah, this makes sense. Pointer three is next, and pointer two is previous. Okay, cool. So we got it. We got the names down. That's good. So, all right. So basically, Kerr is going to start at the head, and then we want Kerr to point to the previous. But before that, we need to say that next equal to um, next points to um, Or I can just say that cur, next points at cur.next. Yeah, that makes sense. So I guess we can just say cur.next is equal to cur.next equal to prev. And then we say that, yeah, that makes sense. And then so we lose this. We lose this too, right? But I mean, we lose that 1 point into 2. And then now that we lose that, we can say that, what can we say? We can say that next is equal to cur. No, next dot next. Is that right? No. We can't say next dot next yet. Um, and then maybe we can move cur to next. Yeah, cur equal to next. No. Before that, we need to say that previous is equal to. So previous is equal to cur, and then next is equal to. No. Cur is equal to next. Right. So we did this operation cur dot next equal to previous. Right. So this is gone. This pointer is gone. And now we have to do previous equal to cur. So we still hold that one. Oh my god. Previous equal to cur. And then I just keep alt tabbing there. And then cur equal to next. So cur equal to next. Right? Huh. Cur is equal to next. And then I can say that next is equal to cur dot next. I'm pretty sure that's right. Cause then boom. Right? And we can kind of do the same thing where yeah, so let's just keep doing the iteration. So cur dot next is equal to prev. So cur dot next is equal to prev. So now this three is gone. Now prev is equal to cur, right? And then now cur is equal to next, right? And then cur is equal to next, right? And next equals to cur dot next, which is here. And then I think we had to. I wonder if I can do that because as of right now with this iteration, um, this three is lost. So what can we do? We can either say like at the end we can say that cur points to previous. Cur dot next points to previous. And then we can just return cur. Right? I think that's okay. Or maybe we can just go through another iteration. I'm not sure if there's like an error with that. Where cur dot next points to previous. Right. And then previous points to cur. Then cur is at next now. And then next is equal to something here, but it's gone. I don't know. I think that could work. Maybe if we do like while cur. Yeah, I think that could work. So you can say like while cur do this. While cur exists, do this. We can do that. I think that could work, but maybe there's an error. And then instead of doing this, we can just say return previous. So I think I'm gonna do that. That makes it works. I think it might work. We'll see. So I'm just gonna make this our plan, copy paste it here. And then I'm gonna just basically follow that plan in code. Um, yeah, so basically we're just going to iterate through the list, but first we have to set up our variables. So cur is equal to head, and then prev is equal to none. And then next is equal to cur.next. And then let's see. Then we got to iterate through the list. So while cur, we got to say cur.next. Prev, and prev is equal to cur. We're basically doing our whole operation that we just did. And next is equal to cur.next. And we just return prev. So this should maybe work, I'm not sure, because in the end, cur, no, in the end, next points to cur's next, which is none, or like, it's out of range basically, but we'll see. So let's go make our base case. Let's go make our test case, I mean. So head is equal to list node one dot next. Okay, so then I'm gonna call list of head, and then I actually need to like make a function to kind of print out lists. So print list. It's gonna take in head. We say that the root is equal to head, and then we can say while root just print out file, and then root to root.next. So yeah. So let's call print list the argument of this actually. Yeah, and it should work. So let's go run it. Sure, it won't work. We'll see. Yeah, it's out of range. Yeah, I expected that to happen. So I guess what we can do, um, we were at this point, right? Cur next, stuff like that, right? I can say like while next, I guess. So while next. Um, then at the end we just say that cur dot next points to prev, and we can just return cur. See. Okay, cool. So I did do it, but I don't know if there's a better way. I mean, I'm pretty sure there's a better way. I think what I did was it was okay. Um, let's just see if it actually works in LeetCode though. What? Oh yeah, 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 yeah. So basically, so if if not head, if not head, then return none, I guess. Right? Like that makes sense, right? It was a test case though. Yeah, yeah, that makes sense. Okay, cool. Okay, so if not head, and just return none. And it works. Awesome. Yeah, so that's my solution. I'm pretty sure there's a better solution out there somewhere, but I made it work, so yeah. To review the time complexity and space complexity. Time complexity is just O of n because we're going through every node once. And then for space, we're using O of 1 space because we're just using pointers to solve this problem, not using any like extra linked lists to kind of reverse the list. We're just using pointers to reverse the linked list. So yeah,